Mhm.
So first of all, to introduce myself, so I'm Mohamed Turkanovic. I'm from the University of Maribor in Slovenia. We are the second biggest university in Slovenia in terms of Slovenian size, of course. I'm heading a laboratory for blockchain. We are a team of researchers who develop and do a lot of research on professional and scientific level on terms of blockchain technology as well on decentralized everything, meaning from decentralized identity to decentralized storage, etc. Of course, this includes also distributed storage. So we are participating in a lot of European and national projects in terms of decentralized, let's say, X. We have also developed a award-winning blockchain platform for storing micro-credentials. It was an award-winning platform in Slovenia. Of course, it was the best computer science project in 2019. This blockchain platform called EduCTX is also a distributed, let's say, distributed database which enables universities to, let's say, create micro-credentials, and it enables students to hold these digital micro-credentials about their grades, share them, verify them, etc. And this is how we also came into collaboration with Zdenka and also the Technical University in Bern, because they are part of our network. They're also part of the blockchain network EduCTX. So I was told by Zdenka that I should give some short introduction on blockchain in higher education. So I wasn't sure what to prepare. So if you can lead me, I can go in this direction. So I can give a short presentation on blockchain technology itself, or I can skip the basics if you know them and go more into the direction how we have been using this technology in various forms and types. So what would your preference be?
Well, I think that we would like to hear some basics, but without technical details.
Okay.
Just the principle, how it works from the more general point of view,
Okay.
and then to see the potential applications. How do you use it, or how do you see it can be used, and so on, the potential.
Okay. Uh, Fine. So,
One information for you, we have watched the recording from the seminar you had
okay.
in Brno, but we think this was there was too many technical details.
Okay.
So if you can like sum up the main idea from the general point of view, and then spend some time on the potential applications, which was there was some time given to that in that recording, but not so many. So we would like
Okay.
to focus on that.
Okay. Good. Great. Thank you for leading me into the right direction. So you probably already see my screen, right? Okay.
Yes.
So I'm just gonna go through the basics of the principles of decentralization, just to give a short introduction into this. So what's the important part here is that we have a decentralized and distributed system of universities, and I will not go into too much depth. So let's say that each of these brackets is a node. It's a network node, and it can represent one different university, one different, let's say, institution whatsoever. Of course, we can have, for example, two computer servers which represent one university, and we can have one computer server for only one university, and we can have again two computers for a second or a third university, etc. The main point here is that we have different computers, different information and database systems which are decentralized. In this case, let's say we have four institutions which share, let's say in technical terms, database and server and storage capacity. So each of these computers will also be part of a blockchain node. What this means is that we can have, for example, each of these universities, one can be in Czech Republic, one can be in Slovenia, the other can be in Bulgaria, the fourth can be in Germany. It doesn't matter. Point is that they are interconnected. In this case, since they are interconnected, we call this a consortium blockchain. I'm going to write just BC network. Okay. And why is this important? Because a consortium blockchain network is something that we say it's permissioned. Permissioned blockchain network. Why permission? Because just that you put it in context, permissionless blockchain networks are public networks. And these are cryptocurrency networks like Bitcoins, Ethereums, and they are called public because everybody can join them. And that's why they are permissionless, because you don't have to have any permission to join them. A consortium blockchain network is that wise permissioned, because not anyone can join it, not anyone can be a node in it, and you have to have a permission from the already existing parties to join such a network. Okay, why is this important? Because let's say these 4 universities, in our case, have set up such a network. By setting such a network, they have also decided to share their resources. In this case, the most important resource is data. And if you see this, that each of these servers will host a database. And let's say now that we have, for University 1, we have a user. This can be either a student or it can be a professor. It doesn't matter what it is. So what is here important is that in technical terms, when this user generates data and puts data into this network, he can contact his own university. So let's say that we have, I don't want to go into much detail, so interrupt me if I go too many, but let's say that we can have one web portal. So you can have one web page, okay? And in this case, I'm gonna just show you here, you see EduCTX. EduCTX, it has a platform. It's called platform.eductx. It's gonna now connect me to it. And as you see here, it already brings up MetaMask. I'm not gonna show you. So anybody of you can connect to EduCTX. It's a platform, okay? It's one central platform which enables me now to use some business logic, okay? However, now, my students from Slovenia can go to platform, Czech students can go to this. So there is one central platform, okay? And when they go to this central platform and they put some data in it, this central platform will locate the nearest server. In this case, it's going to be the Slovenian servers. And when the student now puts some data into this server, this data will be stored in this computer in Slovenia. And however, it will be duplicated and fully replicated throughout all of the other universities. So automatically the data will flow to this university, to this university, and to this university. And in few seconds, each of these servers in each of these universities will have the same data the student provided. Okay? Why is this good? Because in this case now, the second university doesn't have to ask this university, hey, is there some student who has put some data into it? Because they already have the data, because it's already in their servers, in their database automatically. Okay. Also, why is this important? Because blockchain technology, beside this distribution and replication of data, has also one other important aspect. Beside distributing and copying data in various nodes, it has this principle of using cryptography and digital signing everything. So this means that in classical databases, okay, a person can store data in it, and that's it, by connecting to the database. And in classical terms, you will have your higher education systems or your Moodle or everything or something like that, okay? So you sign in as a Moodle user, and then you store some data in it. Well, while Moodle is connected to the database just by one user and username to the database. It's the Moodle username. It's not a professor this, professor that, okay? There is one user. And when you put some data into it, you do not really sign this data. In terms of blockchain technology, there's always this signing, digital signing process. So for example, let's say that we have here this professor, okay, when he wanted to add this data, which I said previously, before being able to add this data into blockchain, he will first digitally sign this, okay, using his digital certificate. By digitally signing this data before putting it into the blockchain, what do you gain? You gain this immutability, and you gain the verification of data. Okay, because now when this information is here also in this computer, the second university will see this data, and it will see that it was digitally signed, and it was digitally signed by this professor or by the university's account, meaning that they do not have to ask or call the first university and hey, have you really done this? Was this really you? Because it is really him or her or the institution, because prior to storing, it was digitally signed. So by using this, let's say, in a fast term principles, what we gain here is fast data sharing and a common sense of one truth, because once a data is stored in one computer is the same in the second computer. Second principle is everything that's stored in it, it's verified by a digital signature of an institution or of a person. And the third thing what blockchain technology brings to the table is immutability. Immutability means that if, for example, for some reason, let's say, University 2 would say, no, I want to remove this data, they cannot do that because they cannot change the data, because they can change the data on their computer, but when they change the data on their computer, all the other universities will be notified and they will know that some university has changed the data, and this cannot happen. Okay, this is the immutability part. So there's a lot to do with security and then with, let's say, integrity of data. You cannot change it and you fully believe in it. Okay, so if we go now to these are the let's say pluses of this technology, the pros. The cons of this technology are also the pros. So immutability can also be a negative part. So let's say that you made a mistake. Once you put data into the blockchain, and if you have mistaken yourself, well, you cannot delete it. So if this professor, let's say, put this data into the blockchain, and the data was that some student gained grade student X, okay, he has a grade of, let's say, 9. He then digitally signs this information and puts into the blockchain. When he, for some reason, has made a mistake, well, he cannot delete this information. What he can do is he can put an additional information into the blockchain saying that the previous one was mistaken and the new one is the newest version. So that is the point of a ledger. A ledger is a system where you just append data, but you cannot edit the data. That's why it's called ledger. It's from economics. I don't know if some of you are from the economics field. So that's the ledger part. Okay. So, and this immutability can be great, but it can be also a negative part. The second negative part of immutability is, and this sharing of data, immutable sharing of data, is that you cannot share personal data. So let's say that you would put here a personal information about the student, his first name and a second name. Well, if you put his first name and second name and you put the grade in it, and even if you are a professor, you sign this and put this into your database, you have to note that this information will automatically be also sent to Czech Republic, to Austria, wherever your nodes are, even if they are a consortium. So sharing personal data is, of course, crime. And by the GDPR protection, we know that each individual should have the right to be forgotten. So this is a problem, because now some student would say, okay, I want you to delete the information about my grades. Well, since the data was stored into the blockchain, you cannot delete it. You would have a problem. So that's why very few business cases are left for blockchain. So what can be done, and where can blockchain still be used? And this is what we have also done in terms of EduCities. So beside having blockchain, okay, we are having one computer in each, let's say, institution, which Can you just give me a minute, because some post office came to bring me something. Just a minute. So what has to be done, and what we have done, is that, let's say we have created nodes. So I'm just gonna try to do this as fast as possible. So we still have these 4, let's say, servers for different universities, because this decentralized system. And however, now each of these universities has 2, let's say, systems. It has the blockchain part, which is immutable and shared between each other. And it has also this IPFS part. And this IPFS part, IPFS is a data storage. It's just a distributed data storage. Distributed. Okay, so it's a distributed database. It's not a blockchain. Blockchain is distributed, decentralized, and immutable. So we are leveraging now 2 things. If you have an IPFS, a simple distributed data storage, means that the principle applies the same. If you put some data into IPFS, let's say data plus, what will happen is this data will flow to all other IPFS nodes. Okay, but with IPFS, what you can do is, well, you can also remove data or edit data. Okay, and it will then also be distributed, this editing. So it's still shared with each other 100%, but it's not immutable, and you don't have to sign anything. So what we are leveraging, and this is the principle that the majority of blockchain applications are leveraging the same thing, is that if you now have some data, this data can have, let's say, also personal information. Okay, it can have information about the students, etc. So the thing is that what you do is this is what we have done, is we have first used this data and encrypted this data. Let's say we have put this data in a red box. It's encrypted. Okay, and it's encrypted with the student's key. It's a student's private key. Sorry, not with his private key, because that would mean that we know it. It's encrypted with his public key, which everybody knows. Okay, so you encrypt it with his private key. It means that nobody can now open this. So now what you do is you store this encrypted file into the IPFS. Well, if you store it, everybody will automatically have it. We then calculate a hash out of this encrypted key, and we then store this hash into the blockchain as a proof of existence. And this, of course, is digitally signed. Okay, this is again the digitally signed by the professor, by the university, by the institution, doesn't matter what. So what happens now is that each involving institution, let's say an university, will have in blockchain a reference that this professor has put it's really some information in it, because you don't know what it is, because it's just a hash at this time, at this place, and he signed it. However, this university will find on their computer also this document. However, this document now is encrypted because there's personal information in it. And now only the student can decrypt it if he wants to. So let's imagine that we have, for example, here a student who goes to the one university. Okay, he then travels as an Erasmus student, or let's say he moves to another country. He moves to another country. Okay, and let's say this other university is part of this blockchain network. Well, in this case, he doesn't need to bring any physical documents with him that he has there some documents. Well, he can just say, okay, you already have my documents. I only decrypted for you that you can see them, since you already have them, but you cannot see or read them. So this is the principle of it. And this is what we are using within the EduCTX. So this is the main thing what blockchain technology is really being used for. One other thing, I guess, I don't know if you are following what the European Commission brings out in the last days, In the last days, the European Commission has brought out the, let's say, the principles of the European digital identity. And the European digital identity brings forward the notion that each citizen of the European Commission should be in control of his data, and each European Commission or European Union citizen should have should be provided with a digital wallet where he can store his data into the wallet and control with whom he shares this data with. So this is why is this important, because now we go to the part of micro-credentials. And when I said previously that a professor puts some data about the students in it, well, this I called previously data. If we now go into details, this data is actually, if we go into the higher education or into the education domain, should be or is defined as micro-credential. Well, a micro-credential, it's a very popular term in the last few days or few years, because a micro-credential can be any formal, it can be any formal or informal information about some achievement of a student. So an achievement can be that a student has passed a course, a university course. An achievement can be that a student has passed some summer school. An achievement can be that a student has passed some test. It can be some GPAN or anything else. So it can be formal or informal. A micro-credential is just a scheme, okay? It's just a schema to define various types of it. And Europass has done a very good job in defining the core principles of a schema for micro-credentials. Okay, where you have a so generic model where you can put anything into it and it's structurized and it will be standardized. So, but this is on the topics of semantics, okay? Semantics, we talk here about semantics. If we go now into the syntactic, we then talk about verifiable credentials. Verifiable credentials. And a verifiable credential is something that is now really connected with decentralized applications and with the blockchain also. Verifiable credential is a V3C based standard where you actually, what you have is, you have a JSON document, okay? It's a JSON document where you can put anything into this document. So you would have here some, let's say, data. And this data will actually can be this micro-credential. So let's say you put into the verifiable credential, the micro-credential. Now, what you also have is the part of issuer, subject, and proof. Okay? In this case, let's say that we have a professor who is issuing some information about a student, that a student has passed his course. So I'm teaching database 2 at my university. A student comes by, passes my course. So I'm gonna issue him a verifiable credential. When I do that, well, an IT system will do that, of course, automatically. But let's say I would do that by constructing such a verifiable credential. Here, the issuer would be Mohammed, the professor, okay? The subject would be the student. The data would be, well, the micro-credential. In the micro-credentials, we know that there is information about the course, about the university, about the grade, about the ECTS points, etc., all about Europass micro-credentials. And a proof is so Mohammed's digital signature. Okay, so when I construct this verifiable credential based on the standardized version, what I then do is I issue such a document to the students into his digital wallet. So meaning what we will have is, we will have, let's say, these are called self-sovereign identity agents. And I'm just gonna show you what we are currently doing and what we are transforming EduCTX into. So let's say here you have a student, and this student has a mobile phone. And this mobile phone, this mobile phone has an app, okay? And this app, it's called a digital wallet. So when the student has created and installed this digital wallet, the first thing what will happen is he will create his identity. So his identity is created, okay? Secondly, of course, as a university, the university will also have a digital wallet, but it will be an enterprise digital wallet, okay? And their price. This can be university, and this is actually, in the case of Slovenia, what we are now developing is a ministry enterprise agent. So the Ministry for Higher Education will have such an enterprise agent. So what will happen is that the student will now go to the ministry's or university webpage, and there he will try to create a connection between his digital wallet and the enterprise digital wallet of the university or the ministry. I can, if you are interested, I can go into the mock-ups of how this is going to be later on. The important thing is here that when they create this connection, the enterprise digital wallet will then create this verifiable credential as a document and send this verifiable credential to the student's phone. So the ministry will not store this verifiable credential anywhere. It generates it, signs it, and sends it to the mobile phone of the student. And now the mobile phone of the student holds this securely only in the wallet and nowhere else of the student, okay, in the form of verifiable credential. Why am I repeating so much time in the form of verifiable credentials? Because verifiable credentials have an ability to partially disclose information. So partially disclosing information using ZKP. So what this means is that, let's imagine that, I'm going to try to do it like this. Let's say that this JSON document is like a diploma, because a micro-credential at the end is like a certificate. So here you will have information about the student. Let's say it's John Doe. Then you will have here University X. Then you will have here databases 2 information, okay? Then you will have here grade 10, let's say 6 ECTS points. Then you will have here some digital proof, a signature of the university. So this verifiable credential, since it's a machine readable form, can be then represented as a PDF in any way you like, as I have done it now here. But the main thing about a verifiable credential is, since it is stored in a verifiable credential form and in a machine readable form, you can partially disclose this information. So let's say that this student wants to go to Czech Republic, and he wants to apply for study. The university in Prague or Brno, they want from him a proof that he has passed some course, database 2 course, but they are not interested in what his grade is. Okay, they are not interested if he has passed with 6 or 10 grade. It has to be some grade. Okay, so what the student could do is he could pass a form of this verifiable credential, which is only partially disclosing the information. So he could provide this information: John Doe, databases 2, without the university, without the grade, but with all other information. And the receiving institution would be able to verify that even if the only partial information was provided, that they can know that all the other information is still legit and verified. And this is possible through the ZKP protocol, Zero Knowledge Proof protocol, but I won't go into details in this. So this is what happens now, and this is what we are also transferring EduCTX into. So meaning that when a professor will actually now put some information, a grade for the student, we will create such verifiable credentials in the background, this verifiable credential will be signed by the digital signature of the professor, and it will be then sent to the student to his mobile phone. It won't be even stored into the blockchain. But now you probably are asking, well, where is then the blockchain part? Well, the blockchain part is in this case. Let's say now that here we have the University of Maribor, okay? And now the student has this verifiable credential on his phone. He then goes to the University of Brno or Prague or whatever, and he then connects to them, okay? And this is, let's say, University of Brno. And he connects to them and he says, I want to apply for study with you. And he sends them this verifiable credential. It can be fully disclosed or partially disclosed, as I said previously. The important thing is that now Brno will receive such a JSON document. In the JSON document, they will see the information about the student, the proof, and the issuer, and they will see, okay, University of Maribor. And they will see, for example, some information. But the thing is that besides that, how can they be sure that this diploma is still valid? What if, for example, University of Maribor has revoked this diploma? And they cannot see that because the student shared with them the information. So what they will do is they will use the blockchain technology to verify that this is the last instance of this diploma. Because what I didn't say previously is that when these verifiable credentials will be created, a hash of those verifiable credentials will be stored on blockchain. And in the case that a diploma would be revoked by any means, I don't know why, again, a reference to this would be put in blockchain. So meaning that Brno would now be able to verify that this verifiable and micro-credential is valid, and they would use blockchain to see that this is maybe not revoked, that this is the last version, and they will also be able to see who the issuer of this diploma really is. So I will just introduce you also to one important concept that you should note is EPSI. I don't know if you are aware of the European Blockchain Service Infrastructure. So you probably know about eIDAS. Do you know about eIDAS? Okay, so the thing is what we have in Europe, I'm gonna start with eIDAS and then go back to the EPSI. What we have in Europe, each member state has a national public key infrastructure. So you have your own qualified digital certificates. I don't know how fully digitalized are your countries, but in Slovenia is, let's say, somehow digitalized, meaning you can do some e-government things digitally by using your qualified digital certificate, which was provided by you from the government. The problem was that now, let's say we have Slovenia and a Slovenian government who now trusts our qualified digital signatures, finally, okay? And then this Slovenian wants to go to Czech Republic, okay? Or he wants to go to Germany. Well, if he wants to open a business in Germany, which by EU law he can do that, well, he cannot do that digitally, because he would need to go to Germany and have a lot of documents with himself to prove that he's an EU member, etc. So what eIDAS is a scheme which enables now the German state to verify a Slovenian qualified electronic certificate. So with eIDAS, Germany will trust Slovenes' digital signature. So Slovenians will be able to open business digitally, even from Slovenia, but in Germany. So eIDAS is a scheme which connects all 27 EU member states into some legal framework that they mutually trust their qualified electronic certificates, which benefits the digitalization process. And EPSI is something that the EU has established, and its EPSI stands for European Blockchain Service Infrastructure. What this means is that the EU Commission has set up for each member state a blockchain node. So each member state from Slovenia, Germany, Czech Republic, Austria, and etc., etc. These all member states have now one blockchain node, which is connected with all other blockchain nodes. Okay, so now we have a European-wide infrastructure where we have blockchain nodes already connected and already functioning. So it's a consortium blockchain node permission, meaning not anyone can join. It's governed by the European Commission and the member states together. So why is EPSI needed? Because EPSI will now hold so-called trusted, among other things, trusted, let's say, issuer registry. Trusted issuer registry. It will also hold a list of trusted, accredited institutions or accredited universities. It will also hold a list of trusted micro-credential schemas. It will also hold a revocation list, etc., etc. Okay, what this means is the European Commission will now enable that when one university issues a verifiable credential to the student using this enterprise, let's say, agent, this enterprise agent will have to connect it if it wants to be legally compliant, of course. It will have to connect with EPSI and put a reference about this verifiable credential into the blockchain. Before being able to be recognized as an issuer of a micro credential, when the University of Maribor, for example, creates this enterprise wallet, it will have to be registered into the trusted issuer registry. And since micro-credentials are standardized, or let's say semi-standardized, they can be various types, formal, informal, various types of joint degrees, etc. Well, when you once create one schema, you also have to define it into the trusted schema registry, etc. So this EPSI is already a functioning service infrastructure, which will now be promoted and used by various member states, etc. So if you just allow me, I'm gonna show you few things. I know we are recording, but I guess I won't share no big.
Well, we can pause it if you wish.
Yes, if it's possible.
Thank you.
So these are two main differences, just to be sure that I've been clear. The first thing which I explained is in terms of what blockchain really is: decentralized, immutable storage, which has its pros and cons, of course. Then I explained you, because of GDPR and the mutability, there is a problem, but there is a solution using blockchain plus a distributed data storage, where you can then encrypt files and still be compliant with GDPR. And this is what we are using EduCTix. And this is still decentralized and distributed. And the other thing which I then skipped to was the new, let's say, the new goals which are currently where blockchain is currently used, and it's used in terms of verifiable credentials, and where we are now following the logic of having these digital wallets where you have full control of the students in this sense. So I hope I was clear enough. I already see I talked for 40 minutes. So I guess if you have any questions, I'm
thank you very much for a nice presentation. And now it is time for questions. If anybody has a question, so please come in. Before anyone else steps in, I would like to ask a question which I didn't see in the process, because I understand that the digital wallet is a secure space in my mobile phone where I own the data. So I skipped the question of how large the space in the mobile phone must be for all my credentials and data, if that everyone every university in the world can issue for my account. But my question is, okay, so if I understand it correctly, I, as a student, apply to the Ministry of Education so that they issue the certificate or diploma and send it to my wallet. That means to my phone, and there it will be nowhere else. So my question is, how does the Ministry of Education know that they can issue the certificate and where they can take the data, where they will take it?
Okay. There were a few sub-questions in it. Uh, if I remember the question, one of the sub-questions was the storage. Yes, of course. Uh, there is some storage consumption, but considering that these verifiable credentials, they are JSON documents, they are not so big. They are maybe maximum 100 kilobytes. That's not really big for our smartphones that we have today. And even if you have, let's say, 100 informal micro credentials, that's still a few megabytes. So I don't think there will be huge storage consumptions on the smartphones. To comprehend this, there are, I don't like to talk about this, but there are solutions that some digital wallets will be in the cloud. But this is really, to be frank, really, which word should I use?
Yeah.
Stupid solution.
Yeah,
Well,
okay. I understand that this is a nice solution because it stores all the data is stored in each person's mobile phone, and that is good because no one needs to have a big servers with a huge amount of data, and this is smart. I see that, but the question was, how does it get into my mobile? Because I understand that the ministry sends it, but how does the ministry know that I got the credential? They must be somehow informed.
Okay. Well, I put the example in terms of Slovenia, where the Ministry of Higher Education of Slovenia will send the students their micro credentials. But in Slovenia, we have a centralized system, meaning the Ministry of Higher Education has all the diploma evidences already at their disposal. So when a student finishes, the universities are obliged to send the diploma to the Ministry of Higher Education. That's why they know about that. However, for example, in our project that we are part of, it's an H2020 project. There's a Portuguese university, and they will issue their students micro credential. It's not going to be the Portuguese ministry, but the university itself, because they have other system. And it will be, in this case, this verifiable credential will be signed by the Portuguese university and not the ministry. In case in Slovenia, it will be signed by the ministry, but because the ministry already has this data.
Yeah, I see. So in the Portuguese case, if we take it as a model, it can be that my university issues the certificate or diploma to a student. So when the student logs in and applies for the diploma, the data will be sent to his diploma and deleted from the university server, or does it stay there?
It will, what can happen is the student can ask that the verifiable credential to be sent to him. And that's a check. What he can say is, I want to exercise my right to be forgotten and request from the university that the data from the servers will be deleted. He can do that if he wants to, but that would be really not the smartest thing. But at least by the laws of Slovenia, the universities are obliged to hold the evidence about him for life. And I don't know if he would really have the right to hold this right to be forgotten in such a case. But the universities can still store the data on their servers. What the main principle is, in Europe, we have this single digital gateway principle. It's called SDG. I don't know if this rings a bell, but the thing is that, the European Union wants to now to emphasize this exchange of information. And as I said, let's say that we have, in case of Slovenia, and we have Germany, as I said previously. Let's say we have a Slovene citizen who wants to open business in Germany, okay? Open business. In order to open some business in Germany, he would need evidences that he is at least a Slovenian citizen, an EU member state, that he is not a criminally, let's say, that he hasn't have any criminal activities. And then he would probably, again, need some, I don't know, some other evidences. So what happens now is that there is, the German state will have a web portal, okay? And using this web portal, the Slovene citizen would need to provide this information. What SDG, the European Commission, has put forward is that now, if the user gives permission to the German government can by themselves go to the Slovene government and say, look, there is some Slovene citizen, he wants to open up a business in Germany. We want to know if he has any criminal activities. He has given us the permission to ask that. And the Slovenian government will just give them all the information. Okay? And this is the single digital gateway. But this is not the same principle as with the self-sovereign identity principle. In here, what you have is you have this triangle. You have the student here, or the person here. He collects his information in Slovenia, whatever he needs, and he is the one who says, okay, I provide you the information which I like. You are not allowed to ask anything about me by yourself to anybody who has this information about me. So that's the core principle of holding your data, controlling what you give to anybody who is asking.
I see. So basically, this is somehow changing the current practice that the German university will take a phone and call to the Slovenian university and ask, please, can you send us the documents about the student, because we would like to hear more about that and he doesn't provide us.
That's right.
So, okay, so this is it doesn't mean that that this principle is somehow removing the data from the current structures or databases, but it is making it more accessible to the student, basically.
Right. It's actually digitally transforming the current processes. So let's say what happens now. Let's say we have a Slovene student. He has passed the first Bologna cycle in Slovenia and he wants to apply in Germany for the second Bologna cycle. In order to apply for the second Bologna cycle, he needs to prove that he has passed anywhere 180 ECTS points in any EU member state and first Bologna cycle. So what he can do is he has to print out his diploma and send it to the German university. When the German university gets this diploma, it's not machine readable. It's a scan, it's a PDF, and they are not really sure that it was not in any case fabricated. You know, it's digitalized, digital world. So what the German university wants, maybe they want from a tax lawyer, or how do you say that he gives a document stating that this copy is the same as the original one, or they call the Slovene university to see if it's real. And what they also do is they probably will want to know if this Slovene university is even accredited. Okay, so and what we now have, the principle stays the same, but with this approach, the student will send his verifiable credential. By sending the verifiable credential, it's in a machine readable form. It can be automatically verified that it was not tampered with. And by connecting to the EPSI services, the German university would see that the Slovenian university is an accredited one. So all this calling and verifying is done automatically. There is no need to do any verification beside maybe some details.
I see. Yeah. So thank you. I think I understand the process now. Are there any questions, or anyone else anyone else have a question?
So if maybe I can ask, my questions was about the administration. However, you, Mohammed, explain it very well. That in the different states there are different models which can be used across the Europe, where the data are stored, for example. So the approach, or my question will be how difficult it will be for someone who would like to join this blockchain consortium. So it will be on the base of the contract or some kind of approval, and to starting to be a part, to be a member of such a blockchain community. What does it mean for such a university or institution? So how difficult or what shall the institution prepare, or how to be prepared for be included into this community, into this blockchain system?
Okay, great question, Zenka. Well, if I go back now to EduCitic's current version, which also your faculty is part of, if you remember what we have there is, I explained to you that in that version, we have a consortium network between universities, and it's a blockchain network. I also explained that in this case, what we are doing is when a professor generates an evidence about a student, he digitally signs it and sends this information to these consortium blockchain nodes. Prior to that, we encrypted because of GDPR, etc., etc. The current version of EduCitic's required for a university to join such a network to recognize EduCitic's. Okay, that they say, okay, we recognize that the nodes which are part of this are really universities, accredited universities. Again, what they then would need to do is they would need to add an additional node, because in order to have a secure blockchain network, the bigger the network, the more secure it is. And these are, in technical terms, what you would need is have a node. This is not really problematic because there is no mining process, to be clear. We are not mining any cryptocurrencies. These are just simple virtual machines storing data, nothing else. And then again, you would need to recognize EduCitic's, because as you see here, for example, I'm going to share now. I'm going to again open platform EduCitic's. You see what I can do here. I can issue a certificate. If I can go here and I can issue, I have a form here where I can say, okay, title, let's say database course, past course or something. I can put some unit ID in here, achievement, certificate type, value, let's say 10 ECTS points, full description, and then I can sign this to a student. Well, the thing is that this information will be shared through the EduCitic's, and the universities would then have to believe this. Okay, so there is no contract needed for us to join, but your university would need to say, yeah, we trust this platform. It really rings a bell to us that this is blockchain behind of it. And in order to facilitate this believing, that's why we emphasize that also the university would set up an additional blockchain node that they see that they also have this data. However, as you see here, this platform already functions 100%, okay? But it is manual, okay? You would have to put all the information about the course and the student manually, okay? And this is quite labor intensive. And no administrative worker in your university or any professor will do that, because he will, believe me, he will probably kill you when you say to him, you have to do this now for all of 100 students that you have. So what would be needed is that you integrate EduCitic's into your Moodle, into your online student systems, etc. Okay, because what would really be useful is that your professors use the same systems as they use, but that system would do the job of blockchain and EduCitics in the backstage. And we enable that through APIs, interfaces. We have them, okay? They are prepared. But what we come to a big stop is with universities that they say, okay, but we need to change our student systems. And we say, yeah, unfortunately, we cannot do that for you. You have to change your system to connect to our APIs that you facilitate and that you use the EduCitics. And in this case, they don't even have the funds to do that, or the resources, or the willingness to go into this slightly changing of their system. They don't change anything. They would just need to connect to the APIs. Okay, so if I answer the first question, you need to trust EduCitics. You can do it manually, but you won't probably want to do that. So you would have to adapt your systems to use our APIs. Okay, but this is for the first part of EduCitics. And because we have such big problems, we knew that we won't gather much traction. So we started to go into the direction of digital wallets, where you don't need these nodes. And thankfully, now the European Commission and these standardized bodies as the V3C came to the same conclusion. And if I go back now to this example, in this case, nothing is needed. Just organizational changes are needed for universities. So, well, sorry, not nothing. You would need to have these enterprise agents which enable you to actually generate these verifiable credentials to your students. So you would need to have some resources to use such enterprise wallet integrated into your information systems. And they would then be able to generate these verifiable credentials and send it to your students. And you would still be able, using these enterprise agents, you would be able to receive also verifiable credentials from other students. So in technical terms, there are some resources needed to use such digital wallets on the enterprise level.
Okay, thank you very much.
So any questions? Hi, Jon Freyr, Oud-Burg. No questions?
No questions for the moment.
No problem.
Okay, I have one actually, because we are talking about students, diplomas and certificates and so on. But I have a practical question, because all of us here, we are working on projects and sometimes from time to time, the other universities, our partners, or even the national agencies, they require some documents and certificates from us. And usually, or before COVID, I would say, what they wanted was either to print everything out and send by regular mail, or to make the thing scanned and send by or upload somewhere these electronic documents. But after this COVID came, they stopped to trust to hand signed and scanned documents. So now they are more and more requiring documents that are that have a digital signature, like qualified digital signature. And this is an issue because usually there is only a few employees or people at the university who has these digital signatures, qualified digital signatures. So my question is it possible, and how could we use these ideas for our project management purposes? And this is, I mean by this, that one university issues a document and provides it to the partner university, which needs to check the information and put it somewhere in the database for the national agency and so on. Do you see, how do you see this application?
It everything depends on the level of assurance, and this is also something that is well discussed in the EIDAS in EPSI, because if your universities, by some legal requirements, require from other partners a qualified electronic certificate signature, well, in this case, nothing can replace a qualified electronic certificate, because a qualified electronic certificate, it's called qualified because it's legally binding as well as a physical signature in original form by law. But if there, and this is the highest level of assurance, that you have qualified electronic signature based on a qualified electronic certificate. But if the level of assurance is lower, for example, if you just need it for you, not for the law, that you know that somebody has proven it, then the level of assurance is lower. In this case, for example, your university doesn't require from your partners that they use a signature which is qualified, but they use some advanced or simplified electronic certificates. And if this would be the case, you could leverage, for example, also EduCTIX or anything else. Because in this case, what you would do is you would use a simple software like a MetaMask. It's a plugin where you can create 100 or multiple accounts, as you see here, create account. And what it does, it creates for you a certificate. But this certificate, it's not qualified because it was not provided you by the government. You have created it by yourself. But if you can establish then with your partner universities the trust that the new documents that you sign using MetaMask's account are assured enough for all of you, then you could use such networks. Everything depends on how much trust you require from your processes. That's
well, we are talking not talking about grant agreements or partnership agreements, because they're usually the qualified certificates are required. But we are talking about things like timesheets and I don't know, some travel reports and such stuff, which sometimes are required to prove something, that something has been done or visited, or maybe lists of participants or certificate of participation in an event, something like that. So my question is, because here I see there is the enterprise wallet, like university wallet. Is it possible to use this university wallet to create accounts for university employees with this MetaMask, so that one university creates a few or several accounts for its employees, the other university creates several accounts for the other university employees, and now these employee accounts would be used to exchange the documents between the universities on this level? Is it realistic? Like that?
It is realistic, and I would just introduce one concept which is called verifiable IDs. Let's say we have this enterprise wallet, enterprise digital wallet, okay? So, and let's say it's in possession of the Ministry of Internal Affairs or the Public Affairs. It doesn't matter which ministry it is. And then we have here a citizen, and I'm going to show you this example and then go back to your question. And this citizen has this, we call mobile edge wallet, a mobile digital wallet. So as I said previously, you will create a connection between these two, enterprise and mobile digital wallet. And when you verify to the ministry that you are really who you are, this can be done physically or on any way they seem enough by the principles of know your customer, right? what they will do is they will create a verifiable credential. Previously, I talked about verifiable credential, which are micro credentials. They are quite confusing maybe sometimes, but this verifiable credential can be in the same form. There could be an issuer, there can be a subject, they can be a claim, and it's always in this form, and then there is proof. Okay, and the issuer in this case is the ministry. Okay, the subject in this case is this person. The claim is that he is a citizen of some member state, Slovenia, for example. And then here is a signature signed by the qualified electronic certificate of the ministry. Okay, so what is going on now is that this person here has in his wallet an EID, a digital personal card, because in this card there's a statement that this is this person and that he's a citizen of this country. So, and this is the highest level of assurance because it was signed by the qualified electronic certificate of a ministry. Now, if we go to the same thing and just say that we have a university and an employee, this employee will use the same digital wallet as previously. In this digital wallet as previously, he will already have a verifiable credential, but this verifiable credential is stating that he's a citizen of Slovenia. He now connects to the enterprise wallet, enterprise digital wallet of the university. And he requests from the university a verifiable credential stating that he is a professor. So now they create a verifiable credential, which again is in the same form: issuer, subject, claim, proof. Now the issuer is the university. The subject, well, it's the same subject as previously, the same person, right? It's to him. And the claim is he's employed as professor as there. And then a digital, then they can sign it using a qualified electronic certificate of the university, or they can sign it using some blockchain digital certificate. Okay, it doesn't matter. A verifiable credential has a structure. What you put into it, it's your thing. You can put and sign it using a qualified electronic certificate, or you can just use electronic certificates, which are maybe just based on blockchain. Now the important thing is that what you asked me is, if now there is a third partner who is also a university, if this third partner has an electronic digital wallet, well, he can connect with your employee, and this employee can send him two verifiable credentials. One verifiable credential stating that he is really who he is, and another verifiable credential stating that he is employed at your partner's institution. And then he would send another verifiable credential, and this could be the timesheet that you said that he has traveled so long, or because what he can do is you can create your own verifiable credential. Even if you have a mobile wallet, the principle will still be the same. You will have issuer, you will have subject, you will have claim, and you will have proof. Okay, issuer would be me, subject would be me. I claim I traveled to Germany, for example, at that time, and I would sign this using my electronic certificate. So this is as a statement, and you would then send three documents. They could all be verified. One stating that you are really who you are, second that you are really employed in this university, and the third one, verifiable credential where you state and sign that you have traveled for so much time or worked over hours or I don't know what.
Okay, I see. I have one question. In this last case, when the issuer is me and the subject is me, and I claim that I traveled to Germany, I suppose that this would be enough for my university.
Yes.
But it perhaps will not be enough to the partner university who is
That's right.
managing the project or for the national agency. So is it possible if I issue this certificate that someone else from the university, like my boss, for instance,
Signs it, right?
will signs it,
Yes.
or is it better that he issues the certificate?
Well, as I said previously, your university could create yourself to you one verifiable credential that you are employed at the university, and another verifiable credential where they say that you have traveled, and they sign it.
And who then signs the document that I traveled? Is it my boss or is it the university?
It can be your boss or the head of the university.
Well, we want to avoid the heads as much as possible, of
In
course.
this case, it can be your boss.
Okay, so then the third I will send to the partner university, or not me, perhaps it will be my boss or the project manager. The project manager will send perhaps three verified credentials, and that will be that the project manager is who he or she is, then that he or she is employed at the university. And the third one will be that this project manager confirms that the other professor traveled to the Germany. Is it correct?
You are correct in terms of the quantity and the versions of verifiable credentials. Yes, he would send three. He would send that you are who you are, that you are employed where you are, and that you have traveled where you have traveled. But you cannot send, your boss cannot send a verifiable credential where you are the subject in it. That's not possible. Technically, it's blocked, because in this case, he would present to some other university information about yourself, and this would be not user-centric. So what you would need to do is you would need to request from your boss, say, please confirm that I have traveled to Germany. He would create to you another verifiable credential in the same way as I said previously. Here you would be you, and the subject you be that you have traveled to Germany, and then he would sign it with his qualified certificate. And then you would send your partner the verified credential of your boss, because he said that you have really traveled.
Okay, so the only change is that we have the same certificate. Issuer is me, subject is me, claim is I traveled to Germany, but
the
the
issuer
proof.
is boss.
Okay.
Subject is me.
Okay.
Claim is traveled somewhere, and signature of boss.
Okay, but then, as you say, the issuer.
You hold this. Okay, this verifiable credential is in your now wallet.
Because I'm the subject.
Because you're the subject.
So then it is me who has to send it to the other university.
That's right.
Okay. Yeah. Well.
And the beauty of this is that the other university can see it's really you, and they can see who has put this, who has claiming that you have traveled, and they can also verify using the certificates and the signature that it's really your boss who has signed it.
Well, yeah, thank you. So now I understand the process and I see how it works. So yeah, thank you.
Yeah. So you are gathering in your digital wallet, which you control, various kinds of verifiable credentials, and that's why they are so cool, because verifiable credential standard just defined the outline. What you put into it doesn't matter. So
I see.
You can construct in various forms of it.
Yeah, thank you.
You then control what you want to share. If you want to share with the other university that you are a citizen or not, it's your part. Or you can share just one verifiable credential.
Yeah, I see. So that is a very nice idea and the system. but I'm not sure how and whether and when it will work in the case that I wanted to do it, because in this case, how it is done. So now it is me as a project manager who collects all the documents and then provides it to the other partner university or to the national agency. And that's quite easy, because I just tell the people, you give me the documents and I'll send it. But in this case, in the case of the verifiable credentials, that would mean that I need to somehow make the others to send it to the other partner or to the national agency. And that might be fairly difficult.
Yes, I know
as
what you
I
mean.
see it now.
Yeah, well, in technical terms, while you received these verifiable credentials, for example, you are a project manager and you have received 5 verifiable credentials from your partners, there is no technical way that it is possible to prevent you to send it further on. But when you send these verifiable credentials to your coordinator or whoever checks your books, they will see the state as you were given it. Okay, and in some cases this is enough for them, but you would of course need to inform your colleagues that you have provided this personal information to others, but this is, in your case, it's normal because they have done it for this reason.
Yeah, I think we need to think about it and discuss, because this is, on one hand, this is a beautiful idea, but on the other hand, it may also have some drawbacks.
Probably, yeah. Probably there are few drawbacks which need to be, let's say, solved in organizational way. Yeah, but each change requires also some changes in the process of how things are done currently. Yeah.
Okay, then I have a different question, and that is, we are talking about, well, it is a blockchain structure. There is a blockchain structure for verifications. So as far as I remember, in the blockchain, there is a consortium, and the consortium makes decisions. So my question is whether it is possible, if, for instance, we have 5 universities in the blockchain, in the consortium, and what if 3 of them say that some information should be removed or deleted or something like that, and the 2 are against it? What would happen? Is it possible at all?
Yes. So what it is possible, it's if you have a consortium, what can happen is you cannot force the other university. Let's say that you have 3 universities who are for the change, 2 against it. What you can do is, since you have the majority, more than 51%, you can fork your current ledger, change it, and start anew, including the change that you have provided. But you cannot force the other 2 ones that they also delete or change it. If they do not want to do that, well, they won't do it, but they will not be part of your new chain. If I don't know if I can go into much detail, if you understand. Because, for example, if I say now that you have these 5 universities, right? And they are all interconnected. Well, since they are all interconnected, they all have the same blocks. And let's say now that the blue ones say that they want to change something. What they can do is they can fork this ledger. they can start anew. And by starting anew, they will create a new ledger minus some data, which was here. They remove it, and they start from now on, adding new blocks. But the thing is that the yellow ones which did not participate in this change, well, they will still be based on this previous ledger, and you cannot force them that they connect to your new one.
Mhm.
If you understand me.
Yeah, I see.
So they are left with the data, and they can say, okay, well, we agree also, and they connect to the new ledger, but there is no way that you force them. That's why it's decentralized. They can be left with the old ledger if they do not agree.
So that means that from certain point, the databases may differ.
Yeah.
Because these are adding new blocks in this way, and these are adding new blocks in other way.
That's right. Yeah. But in this
Okay.
case, you don't have anymore a blockchain of 5 nodes. If they do not agree, you will end up having a blockchain of 3 nodes
and
a
2.
blockchain of 2 nodes.
Okay, so I think that I guess that something similar happens if we have, say, 5 partners and one of them decides to leave the blockchain.
Yeah. So what happens? The 4 of them say, okay, we will fork, and they create a new ledger, and the 5th one will be left with those data which was at the time before the change.
Mm-hmm.
This is possible. This is possible in consortium networks, yes.
Okay.
But if you would not have more than 51% agreement, it's not possible to do a fork.
I see. So I have one last question, and this is concerning security. Because if I understand that if this JSON file, this verifiable credential or certificate is sent to my mobile phone, then nobody can access it unless I somehow open my mobile phone to external tricks, hackers, and so on. So nobody can access it.
Correct. Yeah.
Yeah. So, but also we have discussed that the information that has been sent to my wallet in my mobile phone may still be stored at the university server or Ministry of Education server somewhere else. So does it mean that if these hackers will, rather than attacking my mobile phone, will attack the ministry or university server and steal the data from the university server, they will have the information about me and my ECTS and grades and so on, although they did not have access to my mobile phone. Is that possible?
Yes, of course. This is something that's already now possible.
Yeah. Okay. So it means that the new system is indeed about making the governmental and how to say formal things more accessible for students, learners, and citizens, rather than about the data security.
That's right.
Okay.
It's more in terms of privacy. It's more in terms of digitalizing the processes.
Yeah.
And it's more in terms of control.
Yeah. So it is, the purpose is not the security, because we can't secure it as it is now, but it's about the digitalization and privacy, and how I can step into the process without the institutions having
That's
this.
right, yeah.
Okay.
So let's imagine that if we say it like this, currently, if we take into account the universities have data about us. So, and then we have a process where students want to gain, for example, a student goes to a bank and he wants to open a bank account. And in Slovenia, they get free charges if they are students. They don't have to pay for transactions, etc. But now the bank needs to know that he's really a student. So what can he do? well, the student will need to get a paper from the university where is information that yes, this student really is our student currently. His student status is active. He's participating whatsoever, and because of this signed physical letter of the university, he gets free charges for bank accounts or transactions. So in order to digitalize such a approach, for the student not to go physically there, not to burden the people at university for such papers, etc., there are only one option currently, that the university creates an API for the bank, where the bank would ask through digital means if is this person a student, okay? And for university to open up with such APIs, it would make even more security problems, because then you have an open, let's say, door for possible hackers to intervene to these APIs, okay? So that's why you don't do this. And other option, which is digitalizing the process, is the one that we have now explained it through SSI. The student would request, let's say, a verifiable credential, and then he can exchange this data with anyone who he likes, with the bank, or maybe with the museum, because if he wants to go to the museum, he maybe gets a discount. So again, he would need to go physically to get this paper. In this case, he would send these verifiable credentials to a museum, to a bank, to, I don't know, an insurance company, whoever he wants.
I see. So the question is how it works with the dates, because the students usually are students for a certain period, like the next academic year. So it means that there will be something like that the university as an issuer says that this student as a subject is a student for this period from the 1st of September to the last of August of the next year.
Yes.
Right?
Right, yeah. So what you can, the university could create this verifiable credential, and into it, it can also claim, in the claim part, it can also state valid from to.
Of course.
And the receiver of this verifiable credential would then say, okay, it's not valid anymore, send me another one.
Yeah, and then it says, then it can be also revoked, as you say, or yeah, because sometimes the students finish after the first semester. So then the university must issue another certificate that says the previous one is not valid, but and this one is valid from to. Is that correct?
Yes, yeah.
Okay.
That would be the principle, yeah.
Yeah.
And this is done fully through these verifiable credentials and using maybe blockchain as a ledger for revocation lists.
Yeah, so then I'm thinking from a practical point of view, because there is no issue with students, but with professors there is, because for example, every year I would need to have a verifiable credential that I am teaching this particular subject, and I need this every year. Is that correct? Because
Yes.
next year I may not be teaching it, or the last year maybe I have not taught it. So I need, for each subject I teach, I need a credential for this particular semester, correct?
Yeah, correct, yeah.
Because otherwise I cannot provide or issue the certificates for the students in the course.
That's right, yeah. And these verifiable credentials, you need to understand them as normal papers which you would have in digital form on your wallet, and you have a list of them, and then you can scroll to the list, and if one of them is already outdated, you can delete them if you like them, if you don't want them anymore. Or if by mistake you delete them, you can again go to the enterprise wallet and say, I lost my phone, I lost my verified credentials, so please issue me new ones. And the enterprise wallet will issue you again the same verifiable credentials to your other phone.
Yeah, thank you. I think this will need to be well thought through by the university, because maybe it is not necessary to issue this certificate for the subject for me. It may be just enough that the student will receive the credential after passing the subject, and that will be taken from the university system, like intranet. So it may not be necessary that I'm a verified teacher, because I am a teacher in the university intranet. Yeah.
But in the case of a joint degree between various universities, then maybe
I
something like this.
I see the point now.
And this is why I also wrote to our university is now part in a project. It's called European Universities, and it's called Athena, and we are 5 universities who are now building these joint programs. And now the question is, how do you share data of professors and students between them? Yeah, and we thought using EduCTIX in the previous form, but now we will switch to these verifiable credentials because they are more intuitive.
I see. Yeah, thank you.
Yeah.
So,
okay.
Yeah, any questions? Yes.
Yeah, I have a question. Thanks. I'm just a bit confused about the connection between the digital wallet and the blockchain consortium. I mean, I could have a digital wallet without the technology of the blockchain.
Yes, of course.
Yes, so it's not, yeah, so okay.
Yeah, so the digital wallet story is separate from the blockchain. In the terms of European blockchain service infrastructure, the blockchain is used for, as I said, for accredited lists and a revocation list, a trusted issuer list, etc. And there you find verified information about issuers, about revocations, about etc. So your wallet could receive verifiable credentials from other wallets without any time contacting any blockchain. But in case you wanted to verify that some diploma, maybe you received a diploma and you wanted to verify that this diploma is still valid, your digital wallet would then connect to European blockchain service infrastructure and see if this is the last version of such. Or if the issuer, you will find in the verifiable credential, you will find an issuer. And then you would go to the trusted issuer registry to see if this is really a registered institution or accredited university or accredited insurance company or something like that. Yeah. They are still building cases for EPSI, and these are the first one.
Okay, thank you.
No problem. So if it's okay, I would need to leave now.
Yeah, okay, so let's stop the recording.